Today I'm going to tell you about computer programming. Computer programming is the process of designing and building an executable computer program for accomplishing a specific computing task. Programmable devices have existed at least as far back as 1206 AD, when the automata of Al-Jazari were programmable via pegs and cams to play various rhythms and drum patterns, and the 1801 Jacquard loom could produce entirely different waves by changing the program, a series of pasteboard cards with holes punched in them. However, the first computer program is generally dated to 1843, when mathematician Ada Lovelace published an algorithm to calculate a sequence of Bernoulli numbers, intended to be carried out by Charles Baggett's an electrical engine. Women would continue to dominate the field of computer programming until the mid-1960s. The idea for the creation of COBOL started in 1859 when Mary Kay Hall, who worked for Bug Corporation, set up a meeting to discuss creating a common business language. She invited 6 people, including Grace Hopper. Hopper was involved in developing COBOL as a business language and creating a self-documenting program. Hopper's contribution to COBOL was based on her programming language called Flowmatic. In 1961, Jean E. Simmet developed Formac and also published programming languages, History and Fundamentals, which went on to be a standard work on programming languages. Whatever the approach to development may be, the final program must satisfy some fundamental properties. The following properties are among the most important. Reliability. How often the results of a program are correct? This depends on conceptual correctness of algorithms and minimizations of programming mistakes, such as mistakes in resource management, example, buffer overflows and race conditions, and logic errors, such as division by 0 or off by 1 errors. Robustness. How well a program anticipates problems due to errors, not bugs. This includes situations such as incorrect, inappropriate, or corrupt data, unavailability of needed resources such as memory, operating system services, and network connections, user error, and unexpected power outages. Usability. The ergonomics of a program, the ease with which a person can use a program for its intended purpose, or in some cases, even unanticipated purposes. Such issues can make or break its success, even regardless of the issues. This involves a wide range of textual, graphical, and sometimes hardware elements that improve the clarity, intuitiveness, cohesiveness, and completeness of a program's user interface. Portability. The range of computer hardware and operating system platforms in which the source code of a program can be compiled, interpreted, and run. This depends on differences in the programming facilities provided by the different platforms, including hardware and operating system resources, expected behavior of the hardware and operating system, and availability of platform-specific compilers and sometimes libraries for the language of the source code. Maintainability, the ease with which a program can be modified by its present or future developers in order to make improvements or customizations, fix bugs, security holes, or adapt it to new environments. Good practices during its initial development make the difference in this regard. This quality may not be directly apparent to the end user, but it can significantly affect the rate of a program over the long term. Efficiency and performance. Measure of system resources a program consumes, processor time, memory space, for devices such as disk, network bandwidth, and to some extent even user interaction. The less, the better. This also includes the careful management of resources, for example, cleaning up temporary files. And the first step in most formal software development processes is requirements analysis, followed by testing to determine value modeling, implementation, and failure elimination, debugging. There exists a lot of differing approaches for each of these tasks. One approach popular for requirements analysis is use case analysis. Many programmers use forms of agile software development where the various stages of formal software development are more integrated together into short cycles that take a few weeks rather than years. There are many approaches to the software development process. Debugging is a very important task in the software development process, since having defects in a program can significant consequences for its users. Some languages are more prone to some kinds of faults because the specification does not require compilers to perform as much checking as other languages. Use of a static code analysis tool can help detect some possible problems. Normally, the first step of debugging is to attempt to reproduce the problem. This can be a non-trivial task, for example, as with parallel processes or some unusual software bugs. Also, specific users, environment, and usage history can make it difficult to reproduce the problem. Programming language is a formal language which comprises a set of instructions that produce various kinds of output. Programming languages are used in computer programming to implement algorithms. Most programming languages consist of instructions for computers. There are programmable machines that use a set of specific instructions rather than general programming languages. Early ones preceded the invention of the digital computer, the first probably being the automatic flute player described in the 9th century by the brothers Musa and Baghdad during the Islamic Golden Age. Since the early 1800s, programs have been used to direct the behavior of machines such as jacquard rooms, music boxes, and player pianos. The programs for these machines, such as player piano scrolls, do not produce different behavior in response to different inputs or conditions. Although most of the most commonly used programming languages have fully open specifications and implementations, many programming languages exist only as proprietary programming languages with the implementation available only from a single vendor, which may claim that such a proprietary language is the intellectual property. Proprietary programming languages are commonly domain-specific languages or internal scripting languages for a single product. Some proprietary languages are used only internally within a vendor, while others are available to external users. Some programming languages exist on the border between proprietary and open. For example, Oracle Corporation inserts proprietary rights to some aspects of the Java programming language, and Microsoft's C-number programming language, which has open implementations of most parts of the system, also has Common Language Runtime (CLR) as a closed environment. Thousands of different programming languages have been created, mainly in the computing field. Software is commonly built with 5 programming languages or more. Programming languages differ from most other forms of human expression in that they require a great degree of precision and completeness. When using a natural language to communicate with other people, human authors and speakers can be ambiguous and make small errors and still expect the intent to be understood. However, physically speaking, computers do exactly what they are told to do and cannot understand what the code programmer intended to write. The combination of the language definition and program and the program's inputs must fully specify the external behavior that occurs when the program is executed within the domain of control of that program. On the other hand, ideas about algorithms can be communicated to humans without the precision required for execution by using procedural codes, which interweaves natural language with code within the programming language. A programming language provides a structured mechanism for defining pieces of data and the operations of transformations that may be carried out automatically on that data. A programmer uses the abstractions presented in the language to represent the concepts involved in the computation. These concepts are represented as a collection of the simplest elements available called primitives. Programming is a process by which programmers combine these primitives to compose new programs or adapt existing ones to new users or a changing environment. Computer programmers are those who write computer software. These jobs usually involve coding, debugging, documentation, integration, maintenance, requirements analysis, software architecture, software testing, and specification. My experience with coding comes from having a game sim class in high school. So I'm currently learning the basics of coding using websites such as code.org and code.hs. Coding can be different for many people, while for some it can be hard and for some it can be very easy. My experience with coding comes from a lot of different things I've done in high school. Having game sim from 9th grade year to now. Game coding can be very fun and can be very educational for those who wish to focus more on creating games rather than doing other stuff. Being a gaming creator can be very beneficial to not only you but a lot of other people who love to play games. So my advice would be, if you want to create games, then you should take a gaming simulator class and do your very best in the future that leads ahead of you. Thank you for watching this episode of Adventurous Kids.